Hello, my name is Carmen. I'm from the IDERA marketing team. We're just going to give it one more minute for attendees to complete joining us. Thank you. Okay, thank you all for joining us for It's Not Your Fault, It's the SQL Server Default. During the presentation, everyone will be muted to avoid background noise and distractions. If you have any questions, please add them to the question field in the GoToWebinar panel. We'll leave some time at the end of the presentation for questions and answers. So this will be a 60-minute presentation with Jeff Iannucci and David Terry from IDERA. Jeff Iannucci is a Senior SQL Server Consultant with Straight Path Solutions. He started working with databases as an accidental DBA in 1998, and Jeff has worked with SQL Server database design, administration, T-SQL development, and he loves sharing his knowledge as a blogger, speaker, and course author with Pluralsight, and author of the upcoming book, Learn SQL in a Month of Lunches. So I will now hand it over to Jeff to start his presentation.
Thank you, Carmen. Once again, my name is Jeff Iannucci. It's my pleasure to be invited by IDERA to present this session. It's not your fault, it's the SQL Server default, where I'll be talking about defaults within SQL Server that at scale could turn into some big problems for you. Now, as Carmen said, my name is Jeff Iannucci, and let's see here. If you're wondering who I am a consultant with Straight Path Solutions, where we help clients fix their SQL Server default problems every day. I'm also scheduled to be a speaker at the Data Community Summit 2023 next week. If you're attending, please come up and say hello to me. And I'm the author of Learn SQL in a Month of Lunches. That's the SQL programming language, not SQL Server, as Carmen mentioned. So what are we talking about here today? What are we talking about here today? It's that these defaults at scale can turn into absolute monsters for you with your SQL Server. And when we talk about what kind of monsters? Well, performance monsters largely. We'll talk in this session about different kinds of CPU, memory monsters, things like that can arise from the default settings. We'll talk about security monsters, problems that can have because of security default settings. Integrity and recoverability, since that's a crucial part of any operation. Your data is your most valuable stuff. And inconvenience monsters, just some settings within SQL Server that are probably designed for smaller systems with less activity, but when you need to troubleshoot can become quite a headache for you. So I just want to say before we go any further in this session that I'm not saying you need to make all the changes I'm going to be talking about, although I would definitely say some of them you certainly should change and for reasons I'll explain. But I do want you to strongly consider all of these changes. There may be instances, SQL Server instances in your enterprise that maybe shouldn't have these changes, but make sure you know why you're not going to apply those changes. Maybe there's reasons why you don't want to make these changes. So I just want you to kind of provide some food for thought about what these changes should be. Then I want to start with the very first troublesome default, which is kind of like a troll on a bridge here. and it's kind of a gatekeeper that prevents you from making other changes, and that's the Show Advanced Options. Throughout this session, we're going to be using SP-configure, or I'm going to be talking about SP-configure, and the Show Advanced Options will allow you to see all the things that you can configure. By default, most configuration settings are hidden. So if you try to change some of them, you might get some error that they don't exist. They do, or as it says at the very end, it may be an advanced option, which could be the case. We want to make sure that you see all of these options. And to enable this, you'll just do something really simple. You'll just use SP-configure Show Advanced Options equals 1. Now after that, you'll see reconfigure, and what that means is make this change immediate, because if you don't use reconfigure, your change won't take place until SQL Server restarts again. You may see sometimes people offer something that's reconfigure with override. I would strongly discourage you from using that, because with override could override existing transactions, existing things, and that could break some things, some queries for people. So you don't want to have that happen. But reconfigure is pretty safe. It just means, when transactions are completed or whatever, we'll just go ahead and make this change in real time on our SQL Server. All right, let's talk about some performance defaults related to CPU and memory that can cause some problems for you. Hope you're enjoying the little illustrations here that courtesy of the Bing image generator. The first default is to configure the maximum memory. Now, by default, SQL Server can consume up to 2 petabytes of memory. That's this number that you see here if you look in the properties of your instance. Now, I don't know about you, but I don't have too many servers for clients that have 2 petabytes of memory. I don't think SQL Server needs to go up to that amount. The problem can be if you don't cap that memory, it can be intrusive to the operating system. This configure maximum memory, it's going to limit the amount of memory that is allocated for cache data pages. That's the predominant amount of memory, user of memory for SQL Server. Now, there are also some other cache things like stored procedure plans and whatnot, but this value doesn't include analysis services or integration services or reporting services. So we want to lower this value down so that they're not all treading all over each other and trying and fighting for memory. We definitely want to avoid not just memory pressure, but also anything using the page file. Now, SQL Server by default probably won't use the page file, but if you set SQL Server to use, let's say, all the memory that's available, like it is by default, which would, if your system has, assuming 2 petabytes or less of memory, SQL Server can take that and it's going to be fighting with the operating system. And maybe the operating system goes and uses the page file, which then can affect performance. And the next thing you know, you're getting these calls from users that the database is slow, which is definitely something you want to avoid. So to configure our maximum memory, we're going to do a little bit of calculation. A good starting point is just to take the total amount of memory allocated for a particular server and then subtract either the larger of 4 gigabytes, we want to leave at least that amount for the operating system, or 10% if you have, quite a bit of memory, let's say a terabyte of memory or more. We're going to use an even lower number if you have multiple instances, because we don't want all these instances fighting over memory on SQL Server. You'll have to get out your pen and pad and do some calculations to figure out how much memory each instance should probably have. And if you have analysis services, integration services, reporting services, or even an application that uses the database installed on the same server, you're going to want to make that even lower. Again, we're trying to avoid memory contention. We're trying to avoid anything that's going to push your Windows operating system to go use a paging file or just have any memory contention whatsoever. We can use SP-configure to configure that max memory. And as you see here, the 4096 value, this is the equivalent of 4 gigabytes. This because that value is in megabytes. So 4096 megabytes is 4 gigabytes. Another setting related to CPU and memory we'll look at is optimize for ad hoc workloads. Now, by default, SQL Server is going to cache an execution plan for every single query. And that includes any ad hoc queries, which are, well, a funny way of saying one-time queries that someone just writes. So The problem with this is that each of those execution plans is going to use up a little bit more memory. So what we want to do is, if you want, you can go determine on your own instances how much memory is being used by execution plans. You can go to this link here. You can from Kimberly Tripp of SQL Skills, and she has a query there that's been there for years. It's a very helpful query to look at the plan cache, and you can, as a result, look at those results, the output of the query, and look for ad hoc and see how much. In this particular case, the ad hoc query plans are using almost 2 gigabytes of total memory, which you'd rather have that memory used by data pages rather than ad hoc queries. The thing is those ad hoc queries, they get run once, so you'll probably never use that again. What Optimize for Ad Hoc Workloads does is, instead of caching that execution plan, however large it may be, for queries the first time they are run, it's going to store a stub, which is basically a null value the first time any query is run. And so you'll see it's stored in the DMVs as compiled plan stub instead of a compiled plan, and the query plan column will be null, whereas typically it would be storing some other value. So if this is not, if these queries, the first time they run, if they're truly not an execution, or excuse me, if they're truly not an ad hoc query, then the second time they're executed, the query plan will be stored, and it'll store as a compiled plan. And then, the XML will be presented in the query plan column. This way, then, if you have a third and a fourth, whatever execution, you won't need to recompile that. We'll change that again using spconfigure. Optimize for ad hoc workloads is one. This can actually be a little bit problematic if you have non-parameterized queries that you're trying to track, because those only get executed once and you may want to troubleshoot them. So if you have something like Entity Framework, maybe you don't want to set this. I guess it'll depend on how much memory, when you look at it, is being used by the execution plans. But again, for most environments, Optimize for Ad Hoc Workloads will help free up additional memory for data pages, which is what you want to make your queries go faster, rather than storing execution plans, query plans that will never be used again. Another CPU setting that we'd want to change is the cost threshold for parallelism. Now, parallelism is when you have a query and it has an operation. The query will say, okay, I'm going to have to do this amount of work, and that amount of work is measured in estimated cost. If you go above the default value, which is 5 for an operation within a query plan, SQL Server can say, all right, I'm going to go parallel. I'm going to use multiple threads to compile this. The problem is this value is really low. Queries with estimated cost of 5 on most systems are typically not needing to go parallel. They can probably process in just the same amount of time, if not less, by being single-threaded, not parallel, what we'll call serial. And this unnecessary parallelism can lead to slower queries, because if you've got extra parallelism, first of all, you have to reassemble those threads. There can be extra work in that, but also they're using all these threads, which can create CPU contention unnecessarily for queries that indeed do need to go parallel or would benefit performance-wise from going parallel. Now, what should we raise this to? There's a lot of information out there. If you search around on blogs, what should I set my cost threshold for parallelism to say start at 50. It's a much better value, because queries with costs less than 50 can usually perform just as well or better being single-threaded, being serial, instead of having parallelism. But I would advise you then, don't just set it and forget it at 50. Again, here's another blog post from Jonathan Cahias that contains a query that will analyze your plan cache and tell you, all right, your most frequently run queries, their estimated costs are these values. And so when you look at that, you can see, all right, do I have a lot that are running at 40 or at 70 or at 100 or 200? What's a safe value to raise this or lower this value if needed for your cost threshold for parallelism, to customize it to your actual instance. Again, 50 is better than 5 on just about every instance. but 50 may not be the optimal number. So don't be afraid to dig into this query here and try to see if you can find a better number. We'll change this again with spconfigure for cost threshold of parallelism and reconfigure that as well. Now, if you are using SQL Server 2017 or earlier, you may also need to configure maximum degree of parallelism. The newer versions will kind of calculate that for you and make a suggestion for you on installation for SQL Server 2019 and 2022. But the previous versions, the default will be 0, which is to use all the cores. And if you have 16 or 32 cores, you could have a whole lot of extra parallelism that you don't need that could actually be slowing you down and creating CPU contention. Just as a side note, Microsoft's general guidance over the years has been to set this number equal to half of the processors up to a total of 8, because at 8, there's often diminishing returns of having parallelism beyond 8 degrees of parallelism, using 8 threads for an operation. So that's a separate issue again, but I'm going to assume that you're using SQL Server 2019 for this, or even 2022 for the purposes of this session. So I'm just going to throw that as a note. Are there any questions relating to those? I don't see any in the chat. So I'll just keep on going. If you do have any questions, there is a question section in the webinar app, in the GoToWebinar here. If there are no questions, I'll just keep on going. All right, the next we'll look at the performance defaults that can cause problems related to storage. And the first one is the default file locations. By default, when you install SQL Server, it wants to put everything on the same drive. And you'll see something like this when you look at those default database locations under the database settings of your instance. Well, this can result in storage contentions and IO bottlenecks, because you've got your data files trying to go to the same drive as your log files. And if you write a backup on top of it, then everything else slows down even more. You know, throughput to a drive is not unlimited. There are limitations within your network and with your storage capacity. So this can also become a problem beyond just the IO bottlenecks that are created. Query activity for any database can stop if everything's on the same file location. If just one data file has a growth event, and hopefully you don't have anything set up like it grows 10%, and if it's a terabyte file and it wants to grow another 100 gig, if it can't grow that 100 gig, the query activity stops until that growth event is completed. But again, everything's on the same drive, so if a log file needs to grow as well and consumes all the space on the drive, again, the query activity in that database or other databases that need to have growth can stop as well. If tempdb is on the same drive, it can, one bad query that has to do some massive sort of millions or billions of records that somebody wrote can also cause a whole lot of growth that can consume all the drive space. Or even a backup file or multiple backup files scheduled to run at the same time on this drive, if they're writing them locally, can take all the space. Moreover, by default, a lot of times, SQL Server will try to install into the C drive, which is often the operating system drive. So there are things outside of SQL Server, like some user under their folder, their desktop folder or their documents folder, downloads some massive application they want to install, or there's some system file growth, like the page file, which is set to auto grow, could cause all this activity to stop as well. The point is, don't let the drive with the operating system run out of space, especially, but don't let the other drives do that. You want to modify your file settings, you want to modify your database settings to put these in different drives if possible. We definitely recommend putting your data drive, your files, data files, log files, and tempdb files on separate drives, and they're all separate from the operating system. I'd also recommend changing the model database file settings. That's a database you probably don't look at too often. Before SQL Server 2016, the default settings were really problematic. By default, it created any new database at 4 megabytes, and the auto growth was 1 megabyte at a time. And the log file was 1 megabyte, and the auto growth is 10%. This can create a whole lot of headaches and a whole lot of extra growth events, which slow things down. And when SQL Server has to have a growth event for whatever period of time, it has to say, okay, hold on, query activity, stop. and this could be milliseconds, or this could be seconds or minutes, depending on your storage performance and how much it wants to grow. Now these settings got a little bit better since SQL Server 2016. They start at 8 megabytes, and the auto growth is at 64 megabytes, which is better. We're going to have less growth events, but I want to ask you, how big are your databases, right? If you're creating have created databases and they've grown to multiple terabytes, 64 megabyte growth events are still going to be a lot of frequent growth events. So we want to try to reduce the number of those events. This can be especially problematic for the log file growth events. I don't know if you're familiar with virtual log files. These are the allocation chunks inside your transaction log file. You'll have one transaction log file for your database. At least I hope you have one, and that you don't have multiple. Excuse me there. There's not really any benefit to having multiple transaction log files. But inside your one transaction log file, there's going to be these virtual log files, which are spaces to be used by different processes as they create, as you conduct transactions. Now, I'm going to cover this part up here because I don't want to get too deep into virtual log files, other than for you to think of these as compartments within SQL Server. If you want to read more about those, here's a link that you can do that. But the thing to remember, the one thing I want you to remember about virtual log files is that every time you start up or shut down, or every time you back up or restore, SQL Server has to go through each of these virtual log files within your transaction log to determine, are there any transactions that need to be rolled forward or rolled backwards? So if you have too many of these virtual log files, you're going to slow down your startup and your backup processes. And again, this can be exponentially problematic if you have 100 databases or more on your server, because for each of these databases, it's got to go through and see, all right, what transactions in these virtual log files have to be rolled forward or backwards. Now, what's too many? I don't know. I would say maybe 100 or 200 would probably be the most you would want. There are some store procedures out there that will help you find how many virtual log files there are. You can resize it through shrinking if you need to correct this. But just as a starting point, you definitely want to, I would suggest, increase those default growth file numbers from 64 megabytes to 128 or 256 if you're anticipating your database is going to be eventually hundreds of gigabytes or even terabytes. I'd also want to talk about backup compression. That's something else that can affect storage. By default, there is no compression for native backups. Now, you may be using a third-party vendor, like IDERA has a database backup product. But if you're running native backups, the backup compression by default is disabled. And I don't know why, because for most cases, unless you have a lot of image data or like giant XML or JSON files that you're storing in, very, very variable character max columns or something like that, you can compress that data, which definitely improves performance, not just in terms of the amount of storage you use, but it actually makes your backups go faster for most cases. I know there's a little extra CPU involved in the compression, but with smaller backups, you're going to have less data to write, so they can go faster and they require less storage. Win-win, right? Again, if you want to do this, let me show you an example here. This was something that I did a little while ago. I took one of the, I think it was AdventureWorks DW, and I ran a bunch of transactions in it. And I said, okay, so let me back this up. And I had a full backup and I had a really big transaction log backup as well. This was without compression enabled. Then I did enable compression by default and said, all right, let's back these up. And you can see here, they're fractions of what they were before in terms of size. So again, you're saving space and you're saving time. Two things neither of us have enough of, right? So you can change this again by spconfigure backup compression default. Again, some third-party software vendors will use this value to determine whether or not to compress it. So even if you're using some other something other than native backups to compress your database backups, or excuse me, to conduct your database backups, you may still benefit from this value for enabling backup compression by default. All right, we'll move on to security defaults. I don't see any questions in the question section. So the biggest security default I'm going to suggest is the SA login, which is enabled by default. I don't know if you've seen the news whenever you see about what kind of hacking attempts there are, massive hacking attempts on a SQL Server database breach. A lot of times the defaults, or excuse me, the results come out to say, well, it looks like this attack came because there was a brute force attack on the SA login and someone finally guessed the password. And that becomes a problem because by default, your SA is enabled, this login is enabled, and it's in the sysadmin role, as it should be, as it needs to be. But the thing is that every hacker in the world that's going into SQL Server databases knows you have an SA login. Now, some folks decide, well, what if instead of disabling it, what if I just rename it? The problem is that renaming the SA login to something else can cause job errors with your SQL agent. It can cause other errors because SQL Server has some built-in logic that looks for an SA login. And really, I'll use a quote here from Aaron Bertrand, a prominent member of the SQL Server community, that obscurity is not security. And here's why. You can figure out whatever that login name is if it's renamed with a simple query like this. It's always going to have this same SID, the same identifier. So if you can run this query, you can see whatever the SQL, the SA account was renamed to. So that's not helpful at all by renaming it. Now, you may say, well, disabling it could break things. Actually, probably not, because all disabling does is disabling it for logins, right? It doesn't mean the SA account is useless. Internal processes can still use the disabled SA account. In fact, all we want is nobody to connect as SA, right? So that's why we would disable it. It can still own databases and jobs, and in fact, it's still required to be the owner of the master and the tempdb databases. So there's no real downside to disabling the SA login unless you have some application from a vendor or you set up some connections to use that, in which case I would say you don't want that. Disabling it will also show the failed login attempts in the error logs. So if something is trying to use the SA account, you can track it down by IP address and see if it needs to be corrected. Or if you're having a hacking attempt, you can see, oh, look, wow, we had a whole bunch of failed attempts to log in with the SA login, and maybe have your security folks try to troubleshoot that. Really simple to do that, alter login SA disable. Again, check with your team though before you do this just to make sure you don't have anything currently set up to use that login. I'd also cannot strongly recommend enough to apply cumulative updates. By default, it installs an RTM version, release to manufacturing, I think that stands for, but the cumulative updates, which I'll call CUs, often contain security fixes, and these, even the CUs, sometimes they're in between the CDUs, there are these general distribution releases, which contain fixes for vulnerabilities. These are pretty common. I just took a quick screenshot here from SQL Server Updates, which is a great site to easily look and see what's the most recent version, what are the most recent updates for SQL Server. And just even in the most recent 7 or 8 or 9 releases, there are these GDRs in between, which are addressing vulnerabilities. You should definitely try to apply those. I won't say as quickly as possible, but within, let's say, 30 to 60 days. Excuse me one moment. All right, and the next setting that I would talk about is the remote admins connection, security related. By default, I don't know if you know this, SQL Server reserves one scheduler thread. You have multiple threads for each of your CPU cores, but it reserves one scheduler thread for anyone in the sysadmin group. Now, this is called the dedicated admin connection, the DAC. You may hear it referred to, but it's for anyone in the sysadmin role. And by default, it's only allowed for local connections. Well, most of our servers now are virtual machines or in some cloud environment, right? We'll never actually be a local connection. We won't actually be right in front of the server logging in the keyboard. So enabling the remote admin connections is going to allow us to remotely get the same benefit of using that single CPU thread that's reserved, which can be really handy if you have a whole lot of CPU contention and no one can connect. If that's the case that you find yourself, you can then connect in a very special way using this admin connection, admin : SQL Server 2022. This is how you would do it in Management Studio. And then go in with your single thread and see, all right, what's going on? Do I need to kill a transaction? What's happened? Do I need to restart SQL Server? What's happening inside here? Again, really simple, using spconfigure to enable the remote admin connection. The thing to remember about the remote admin connections is it's kind of like the Highlander. I don't know if you're familiar with that, but then the Highlander was all these immortals that were battling it out, and the rule was there can be only one. The same thing is true with your remote admin connection. There can be only one. There's only a single thread used, so don't use it for routine tasks. Don't get in the habit of having an admin connection used. In fact, you want to have this always reserved in case of emergency. All right, I'm looking here before I start the next section. I'm seeing a question here. I cannot read the question. Can Carmen, are you able to read that question?
Yes, give me 1 second. What is your recommendation on having an alternate to SA and perhaps an escrowed recovery admin account?
That's a great question, and I meant to mention that. If you're going to disable the account, the SA account, yes, it's a good idea if you can to create a second account that we'll call in place of SA, your emergency account. Just don't call it SA, right? Don't call it not SA or something like that. But yes, that's a great idea to have available in case like your Active Directory, Windows authenticated accounts can't work and you need to connect in. The nice thing about that is that no one's going to know what the name is of that account. You can give it just some innocuous name that no one would guess, and give it a very strong password. Great question. Are there any other questions, or was that the only one?
That's the only one I'm seeing.
Okay, cool. I'll move along then to the next bit where we'll talk about integrity and recoverability defaults. All right, by default, you install SQL Server and there's a lot there, but what's missing? There are no default backups and there are no default integrity checks to look for any kind of potential data corruption in your pages. And there's nothing to notify you of these issues by default. So the thing I would want to emphasize here is backups are really important. In fact, I would say that they are the most important part of your job if you're the one who's been in charge of being the administrator, whether by title or just by function, of your SQL Server databases. And I don't want to just say regular backups. I want to say that they can be successfully restored. So we want to talk about things that we can do to make sure not only that we have backups, but that they are successfully restored. Now, you can use native backups, you can use other products like IDERAs to do backups, whatever it is, you have enterprise-wide solutions. If you do use some sort of enterprise-wide solution, make sure that it is application aware. You don't want to just restore SQL Server servers without it being application aware, because what can happen is your log files and your data files may not be backed up at the same millisecond, and there could be transactions occurring in between those files being backed up. And if that happens, your database file and your log file are out of sync and they come up in suspect status, and that's not a place you want to be. That's why you want to restore from native backups. Or use native backups, or at least something that is application aware. You want to use something to set up integrity checks. And you also probably want to set up SQL Mail so that you can get notifications, and then operators, which will be email addresses or distribution lists that can be mailed. You probably also want to set up alerts for some very specific things. By default, SQL Server does not have these set up, but you can set these to automatically write things to the error log so you can find out when, let's say, bad things happen. What kind of bad things? Let's look at alerts for specific severity levels. First, 16, which is any error that can be corrected by the user. These are usually when you use raise error within your code, you'll often do severity level 16. You'll want to know when these things happen, right? So you want them to be written to the error log. Also, 17 through 19 are software errors, and 20 through 25, which are fatal system errors. You'll want to know when these occur and what the actual severity level was. You can use SP add alert to create these, and then just one for each one, you'll specify which severity you want. Now you can also do integrity check errors. I would strongly recommend this as well. There are three specific that I'd want to recommend. 823, which is if you have an IO device error, which means it was having some issues trying to read data pages from storage. Logical consistency errors. If you do have any kind of data corruption, oftentimes it's these. You'll get an 824 error. That means that there's something about the page that's not quite right, the data page. It's usually been corrupted either from something in storage or from an abrupt shutdown. And the 825, which is read operation, had to be reissued. What that means is that SQL Server told Windows, go read a page, and Windows said, I tried to read that page, I'm gonna try again. And that's a bad thing. It shouldn't have to try again. It should be able to get the page each time. We'll do this as well. But instead of severity levels, we'll do this with the message ID as shown here. We'll set up and use add alert for each of these. I'd also recommend you enable backup checksum. By default, there's no checksum used with backups. Now, what is checksum? Checksum is a calculation from the data page bytes used on each data page. And it basically says, well, there's this much data on this page, so I'm going to have this value. And the advantage of this is going to help us ensure that the backups are restorable. It's going to create these checksum values for each of our backup, or for each page that it's backing up. It's a small operation. It does add a little bit of extra time to your backups, but again, backups are important because we want to restore them. So they're not important just because we wrote them. We want to make sure that they are restorable. So we'll enable backup checksum default here as well. All right, before I move on to inconvenient defaults, do I see another question in there?
Not so much a question, but a comment. Index and statistics maintenance are not set up by default either, and very much needed.
That is correct. I didn't want to get into that too much here because that's there's a lot that goes into that. Sometimes people set up some really aggressive index maintenance that maybe they don't need as much with modern storage systems. There's different kinds of fragmentation that you're trying to correct, internal versus external. These things can be also determined by what fill factor you're using. There's a lot that goes into that, but that's absolutely true. You should look into setting up that maintenance as well. Good point. Okay, and inconvenient defaults, we'll move along here. This is the last section. The first thing I'll mention here is the number of error log files. Now, by default, SQL Server is going to write everything to the same error log file until you restart it. And then as you restart it, it will retain up to 6 archive files. You look under SQL Server logs under Management and Management Studio, and you may see something like this. Well, again, by default, it's going to write to the same file until restart. And so a file like this particular archive file, has everything from July 15th to July 9th. And that's about 2 months of logged events. Now, that's probably quite a bit of data if you have to go say, all right, now maybe you don't have to troubleshoot that particular log file, but if you have 2 months of logged events or more, I mean, really, how often do you restart your SQL Server, right? You could find this progress bar when you try to look into the error log and you're sitting there waiting and waiting for it to open up. Like, I need to go troubleshoot an error, we're having an error. And then you're just, waiting potentially minutes to open up all these millions of records that could be inside the error log file. So that's the question I asked you, is how often do you restart your instances? Now, the answer to this isn't to just restart your instances more frequently. Instead, we have a better solution. We can just create a job to recycle the error log using SP cycle error log. Yay, there's something that's already in there. And what that's going to do is then whatever frequency you set that up to be, weekly, monthly, maybe, I guess if you don't have a lot of activity, but some cases I've seen daily, you can then recycle through the error log so that those error log files are much smaller, and when you need to troubleshoot them, you can open them up and quickly find whatever it is you're looking for. You can control the amount of those log files by using this XP instance regwrite. I know we're writing to the registry, but that's just where these are contained. They're not internal to SQL Server. These are actually external files. And I want to just emphasize here that this value here determines how many you want to keep. Again, you may want 52. You may want 52 files. You may want 12 only once a month. Maybe you want 300 or 100 or whatever, and you want it daily. It depends on, look at your error log files and see what's an appropriate amount of data to be contained within them. Now, speaking of error log files, I'd also strongly suggest enabling trace flag 3226. I don't know why this isn't, because enabled by default. This isn't the default behavior, because by default, SQL Server is going to write all backup attempts to the error logs, including the successful ones. So you can see noise like this in your error log, and your error log probably should have errors, not success messages for backups. You don't want it to be, and I've seen this where it's like over 90% of the information in there, especially if you're doing log file backups every 5 minutes, sometimes even every minute, it's just all this extra noise. Again, 3226 is going to suppress these database backups. Let me give you a scenario here about when you have all this noise. Again, by default in your SQL Server, someone calls and says the database is down, right? And you're scrolling through that error log, all these successful backup messages, and your supervisor is on you like some kind of monster. Now you have a different monster to deal with. I am speaking from experience. This has happened to me. I strongly suggest enabling trace flag 3226 as a startup trace flag. And then also in the history defaults, the SQL agent seems to think that you only need 1,000 rows of history. I've seen agents that have hundreds of jobs, and if you have hundreds of jobs, you're not going to get a lot of history if you only have a maximum history of 1,000. The 100 per job may be successful, but again, if you have a lot of jobs, you might not get to that 100 value ever. And the worst thing in the world is to see something happen to the job and you go to right-click view history and there's nothing there. It's just been already purged away by the minimal values here. What do we set this to? Again, it depends how many jobs you have and how frequently do they run. Maybe you want to raise this to something else. This is an example we can use to set it to double the values. But maybe you can set them, I think the max is 999,999. Yes, that will create 1 million rows in the job history table in MSDB. But is 1 million rows a lot? I mean, that you can still search that pretty quickly. Wouldn't you rather have all that information? All right, finally, the king of all default monsters is the Windows power setting. It's not even in SQL Server. This can affect performance dramatically. By default, by default, Windows treats all computers as if they're laptops and they need to have balanced power and power down. What this means, balanced power will match capacity to demand. Well, if your demand goes down, let's say at the end of the evening, then what Windows will do is it will throttle your processors to conserve energy, which is probably not something you want to do on a server. You probably want that full capacity at all times. So what ends up happening is you get a situation where you've powered down because we have less demand overnight, and then first thing in the morning, your users come in and they start writing queries, and your CPU processors have been throttled in terms of their capacity. And everyone's like, why is everything so slow first thing in the morning? This is what can contribute to that phenomenon. So I would recommend changing this from balance to high performance, where that locks your processors at the highest performance state regardless of demand. All right, let's make a plan here to overcome these monsters. First, we'll look at the installation defaults. When we install SQL Server, let's make sure we change that Windows power. We'll also want to change the default file location so we don't have everything in the same drive if possible. Enable trace flag 3226 as a startup parameter and apply cumulative updates. Don't just leave it at the RTM. We'll also want to schedule backups, either native or otherwise, schedule integrity checks as well, and then set up alerts to let us know if there are any errors or if any data corruption is detected. We use our good friend SP configure to change some of the defaults. We want to show the advanced options so that we can change other defaults. We'll want to set max memory to a reasonable value so that we don't have memory pressure. Enable optimize for ad hoc workloads so that we have more memory available to data instead of query plans. Change that cost threshold for parallelism to 50 and then monitor it and adjust it as needed. Enable backup compression and backup checksum to make our backups faster, smaller, and more reliable. And of course, enable the remote admin connections in case we need to use that reserved thread. And other defaults we want to change, we'll disable the SA login to protect our database. Change the model database settings so that we can control file growth and hopefully don't have a large amount of VLFs then in our data log files. We're going to increase the number of error log files that we can see so that we have more of a history of whatever is going wrong in SQL Server, and we'll change the job history default so we can see more job history as well. And that is all I have. At this point, I'm going to hand it over to David, who I believe is going to talk to you about IDERA Diagnostic Manager.
Thank you, Jeff, very much. Great presentation. I am going to talk a little bit about Diagnostic Manager in the context of what you just discussed. And SQL DM can do a lot as far as monitoring the performance of your SQL servers and give you visualizations both in real time and historically of how these SQL servers are behaving. But as Jeff was talking about, right, there's a lot of configuration settings that aren't appropriate by default within a SQL server, and you may have an environment that needs some modification made to it. So when we talk about SP configure, right, that stored procedure, one of the nice things that SQL Diagnostic Manager does for you is basically list out all those advanced options for you in a graphical interface, right? So I can see, for example, the cost threshold for parallelism, and if I need to make a modification to that, I can edit that directly within the view. So there's lots of stuff in here. Pretty much everything that we just discussed as far as using that stored procedure can be modified in here. So I can change, let me sort by run value because I think you'll see a lot more with things that are actually configured. So max memory, min memory, cost threshold of parallelism, max degree parallelism, even like admin, allowing remote admin connection, that kind of stuff can all be configured directly within SQL Diagnostic Manager through the GUI. Now, you may not need to make some of these changes, but it's nice to be able to come in and look at one of your servers and see how it's configured. And based on the monitoring, you may need to make some adjustments to that, right? So SQL DM is much more than just a monitoring tool. It does have some admin functionality, and that includes things like digging into the log. So when we're talking about how big is the log, and as an example, right, I'm loading in a bunch of these backup events into my logs, which may be kind of spamming that log file. But one of the things that we're doing in SQL DM is we're looking at the severity levels that are indicated with each one of these log entries. And as you can see right here, we have a yellow one, right? So I can sort through this pretty quickly. If I'm in that scenario where my supervisor's breathing over my shoulder and I'm trying to figure out what's going on with this database, I still may have a lot of this message in here that I don't necessarily think is the problem, but I can sort really quickly into these logs and identify warning and critical events that have been indicated within those logs. To continue on a little bit with that story of making sure my server's optimized as far as configuration goes to get the best performance out of it, we have a neat feature within Diagnostic Manager called, and I'm hoping I may not be sharing my screen. Am I? Sorry, guys. I don't want to. I am good. We have a really neat feature called prescriptive analysis within SQL DM. And what prescriptive analysis basically does is it runs a bunch of tests against your servers and gives you recommendations on how to improve overall performance. And some of those tests are around workload, so looking at the queries that are running, looking at index optimization, but some of them are relatively basic, looking at the general server configuration, looking at the general database configuration, including things like processor. Is the server set up for maximum processor performance, or is it set to scale down, based on load, right? So you can run these little tests against the server, and it will come back with a list of prioritized recommendations. Now, In my case, quite a few things in here are kind of related to what we just talked about, right? So I can see in here that, we're not doing integrity checks, right? So maybe we need to go configure that kind of stuff. We have some password issues. I don't personally run with SA account enabled, but it would flag and say, hey, SA account's enabled. You may want to disable that. Databases and different recovery models. I don't have, let me show you this from a different perspective, because I often do make a lot of modifications to my default configuration so that it is optimized. But let me show you from a different perspective. This is a list of all the different things that we can highlight for you as far as changing your server configuration. If we go look at something, for example, like processor, BIOS settings are incorrect. The settings for processor not being at high performance, right? So those sorts of things can be flagged as potentially being problematic for your system. Memory configuration, having your data files and your log files and your tempdb files all in the same directory. Those sorts of things can be flagged as recommendations, so that, frankly, you can go change them and get better performance out of your SQL servers, right? So there's a lot of stuff that this tool has available for you to understand quickly. Do I need to make a change so that we're getting better usage? Another big piece of SQL Diagnostic Manager is alerting, right? So being able to be notified that there is an issue that's going on. And we talked about, setting up notifications, or Jeff talked about setting up notifications for events that show up in the event logs. But at the same time, Diagnostic Manager kind of has you covered there as well. There's tons of different alerts available across Diagnostic Manager, from database alerting, things like, are we seeing auto growth at the data file or the file log file level, right? How full are those files, so that I can anticipate that a log growth or auto growth may be occurring, right, at the data in the log file. There's also alerts coming from the error log and the agent log, and these are based on severity levels for the most part. So if it's over 11, it'll be a warning. If it's between 11 or above 18, that will, between 11 and 18 will be warning. Above 18 will be critical. Below 11 is going to be okay. But under the advanced features of the tool, you can put in flags, right? You can put in text that you want to see. So, for example, if I see a failed login from the SA, right, I can put in, failed login SA text in here, and it will notify me that someone's trying to potentially brute force their way in. And we certainly have job monitoring down here as well. So, making sure that those jobs are running, getting the messaging about the jobs into the tool, and, even backups, right? So normally I'm looking at the jobs in relation to backup health. On the other hand, we certainly will have alerts just straight up on backup. So there's tons of different things that we can alert on. But a lot of the things that are discussed in Jeff's conversation earlier about the defaults are things that we can alert you to notify you, hey, we have a problem here. You may need to go make an adjustment. So SQL DM, it's a very robust solution. The idea is to give you both real-time and historical monitoring around your SQL servers and the performance of these SQL servers. But that's not to say that it can't do some of this admin stuff, right? So being able to get in quickly and make adjustments to how the servers themselves are configured. If you are interested in Diagnostic Manager as a product and you want to download a trial, we certainly have free trials available. If you go out to the IDERA website, under the products drop down at the very top, you'll see SQL Diagnostic Manager right here in the middle. If you click on the Getting Started for Free button right there, it will give you a download link. That download link is going to give you the ability to monitor 15 servers for 2 weeks by default. It'll also get you in communication with one of our account managers internally here at IDERA, who are really great people. They're here to help. So if you need a one-on-one demo with someone on my team, if you need to understand what pricing looks like, that kind of stuff, certainly get in contact with that account manager. They're here to help you. I love that presentation. I think everybody should see that presentation. Experienced DBA who's maybe been working since SQL 7, or accidental DBAs who just are getting thrown, hey, you're the smart guy on the IT team, you're in charge of SQL Server. Well, understanding where the pitfalls are around default configuration can save a lot of heartache and a lot of time down the road. So thank you, Jeff, for that. I'll pass it back over to Carmen and Jeff if we have any more questions. I don't see any more questions right now, but anybody on the line, if you guys do have questions, please type those in. We'll take those. Jeff, was there anything? Let me think. Let's look at resources. So sometimes you don't necessarily know where your files are, right? So if you look at disk, right, disk and Diagnostic Manager will help me understand exactly where or what drives we do have, how much of that data is SQL data, how much of that data is other files from the operating system, how much is used data, how much is free, right? Even getting into file activity. So I can see from the file activity view in Diagnostic Manager where we have separation. So in my case, the data files and the log files are on the same drive, which are D, but luckily the tempdb files, which we don't necessarily see here because I don't have that turned on, tempdb files are sitting over on my T drive, right? So that might take a second to load up, but here are my tempdb files sitting here, right? And you can even drill in, by the way, if you want to understand how tempdb is behaving or how these files are structured, right? We can drill in and look at, here's tempdb, here are the files, what are the size, growth rates, fill factors, that kind of stuff, potential growth. So you can get a lot of detail on that file configuration as well. So very strong tool. It looks like we do have one more question coming in. Let me see what that one looks like. Is it best to set up SQL Server with mixed mode or Windows authentication? Jeff, I'll let you handle that one. I certainly have my opinions, but I'll let you take that.
Yeah, I would definitely set it up with mixed mode. It gives you some more opportunities. Windows authentication only will maybe give you an extra layer of security, but there are some things, as was noted from a previous question, where maybe you want to have an SA login in case there's some trouble and you need to get into your server, and maybe your Windows authentication accounts won't work. Maybe you're having some sort of Active Directory issue, that you can still get into SQL Server, make sure it's running and everything's up. Great question.
Yep, I agree with Jeff's sentiment. It's always a good idea to disable SA. And if you do have any SQL Server logins that are associated with mixed mode authentication, that you should have a very strong password policies enabled on that password, but not having it can certainly shoot you in the foot if you have an AD problem. So I think it's always a good idea to have mixed mode authentication enabled, unless you have some sort of outside entity that's telling you, we're not allowing this because of XYZ control. So certainly if you can get away with it, make sure you have it available in a lockdown format, and I think you'll be grateful for that.
Yeah, I would like to add one thing to that. Windows authentication is probably preferred authentication for users because you can have things like multi-factor authentication with a Windows login, whereas with just a SQL login, it's just a login and password. So yep. As David emphasized, make sure you have very, very strong passwords for those SQL logins.
Yeah, and don't let the whole world know what that password is, because anybody can log in with that account and not necessarily have accountability around it if you don't have the IP address that it came from. So
don't put them in emails or Slack channels or whatever.
Exactly. So questions, looks like we're done with questions right now. I'll pass it back over to Carmen.
Okay, thank you all for attending. Thank you especially to Jeff and David. So yeah, we hope you all have a great day.
Thanks, everybody.
Thank you.
And I think for those who may be still on the line, this was recorded, and we will distribute a copy of the recording out later on this afternoon for those who may not be able to attend, and you can share that internally with your teams if you'd like to share that out. Thanks, everybody.
Thank you.